Okay, so hi guys, good afternoon, good morning for all of you. Thanks a lot for joining this second meeting of the External Vertical Industries Advisory Board of 5Growth. I just want to briefly introduce the outline of today's session. So first of all, we will just go through a summary, a recap of what this is about, and a short round of introduction, because I see a lot of people connected now that some of them didn't join the first time from 5Growth project. And then I will just give the token, pass the floor to our technical manager, Chili, for a status update, together with other people from the project, that we will report on what we are right now, what is the main achievements that we have achieved, and what is next in the project lifetime. And hopefully we will be able to get a lot of nice discussion and feedback, as we did in the kickoff meeting from you guys, and take those input, those suggestions or questions into consideration for future work. So this is from the agenda point of view. So then, just a short summary of what is the External Vertical Industries Advisory Board. Well, this is a body of external people from 5Growth that is meant to provide non-binding technical advice to the PMT, to the project management team of 5Growth, in order to organize the work that we are doing in the project. So for us, this is very, very, very useful, because when you work in a team, at the end of the day, it's very nice to have external views from people very relevant in the industry, in the field, but outside of the daily work basis from the project. So this is, again, I really like to thank you for being part of this and helping us. So in terms of the members, I would like to just do a very short round of introduction. So maybe we can start from the project, from the 5Growth project, and then we go into the members of the advisory board. So let me just start. My name is Carlos Bernardos. I'm from UC3M. I'm the project coordinator of 5Growth. And then maybe we can just go ahead with Chi and the rest of the guys from 5Growth.
Hi, good afternoon. This is Shirley. So I am the technical manager of 5Growth project, and I'm working from NEC.
Thanks, Chi. So maybe Manuel.
Hi everyone, Manuel Lorenzo from Ericsson, Head of Innovation at Ericsson Spain, and responsible for the pilot infrastructure work package 3 in the project.
Sorry, Asier, sorry, I wanted to use the work package order and I missed you, so Asier, please.
Don't worry. Hi, I'm Asier. I'm a consultant from Innovalia. We are working on the pilot on one of the verticals.
Okay, thank you. Then maybe Diego.
Yeah, Diego Lopez in work package order. I'm leading work package 4. So I'm in the correct order. I work for Telefonica Research. And well, we are involved in several of these vertical projects, and mainly in the one of the one that is hosting one of the pilots of the project. So this is Photonic.
Thank you, Diego. Josep.
Hi, good afternoon. My name is Josep Manguez. I'm head of the Communication Networks Division at CTTC, a research center in Barcelona, and in 5Growth, I'm the Work Package 5 leader, which is on communication, dissemination, and exploitation.
Thank you, Josep. Paola?
Hi all, I'm in Ericsson Research in Italy. I'm responsible from COMAU Pilot.
Thank you, Paola. And you are also the innovation manager of the project?
Innovation manager, yes, sorry, innovation manager of the project.
Thanks a lot. And then we can go through the board members. So maybe we can just follow the order on the slide. So Juan Carlos.
Hi everyone. Good morning. Juan Carlos Zúñiga with Sigfox, in charge of standardization and IPR strategy at CIFOX.
Thanks. Then Carlos and Lourdes.
Hello, everybody. Good afternoon. My name is Carlos Romero. I'm working at CETI2. I'm director of innovation. We are involved in everything related with new technologies and tourism application and use cases of 5G in the travel sector.
Thanks a lot, Carlos. Lourdes. I see that I think you are muted.
Good afternoon, good morning, everyone. My name is Lourdes Pedro. I'm project manager at CETI2 and currently involved in the 5G EVE project with the tourism vertical.
Great, thank you very much. And last but not least, Enrique.
Hi, hello everybody. Good afternoon. My name is Enrique Dominguez. I work in GMB. I'm technical expert on GNSS, multi-sensor based positioning, and 5G positioning. So,
okay, thanks a lot, Enrique. So then I think we can just go to the presentation from Chi, and I don't know if Manuel will also explain, and Paula probably, on the different pilots. So please, Chi, you can start presenting.
Yeah. Okay, so I will share my screen. Okay, I hope you see it. Okay.
Yes.
Do you see the slides? Okay.
Yes.
Thank you. Okay. So yeah, I will now start my presentation. So we have the first kickoff meeting in April. So like half a year already passed. So before I go into the update of the progress of the project, I will just give you a very quick recap about overall the project scope and what we are working on. So overall, 5Growth is aiming to provide the technical as well as the business validation of 5G for the different vertical industries. So in this case, we are considering Industry 4.0, transportation, and energy as the three main vertical sector. And we are working on to provide a kind of AI-driven, automated, shareable 5G end-to-end platform solution. In that sense, we have one developing of the 5Growth platform, which is including all our innovations. And this is leveraging on the outcome of the phase 2 5G Transformer project. And then this 5Growth platform is used to manage the infrastructure and resources at the vertical sites. And then it also provides the end-to-end connectivity to the ICT 17 platform. In the project, we have the 5G EVE and 5G VNI as the two external ICT 17 platform. And this provides an overall end-to-end solution for providing the different slides for the different vertical services. So as I mentioned, in the project, we are mainly focusing on the real field trial with the different vertical pilots. In this case, we have two verticals from the Industry 4.0 sector. One from Innovalia, which is a Spanish company, and the other one is the COMAU from Italian. And we also have the one transportation vertical, which is from FSEC from Portugal. And then for the energy vertical, we also have the FSEC, but also from Portugal. So in total, we have 4 vertical pilot and including 4 vertical locations. And for all the pilots, we are going to to deploy the pilot in the vertical premises, and then connect them through the ICT 17 platform in terms of 5G and 5G VNI, and then to provide the end-to-end platform solution for doing the validation and evaluation of the 5G technology for all different vertical industries. So this is the overall of the aim of 5G Growth project. Now I will go into give you the outline of the presentation today. So first of all, I will give you a update of the project status. And then I will give the main focus of this presentation on the deployment of the vertical pilots. In this part, I will show you the current deployment of the different vertical pilot and also including some initial preliminary results. And after that, I will also show you our solution for how we integrate with the two ICT 17 platform. The last part is to give a summary about the innovation we are developing in 5G Growth for enhancing the vertical support for all the vertical pilots. And at the end, a summary. So maybe before I going further, so if you have any questions regarding the slides I'm presenting, you can ask anytime. So for the discussions, but at the end, we will also have the time for the discussion to collect your feedback. Okay, so here I give you firstly an overview about where we are in the project. So this is the overall work plan and time plan of the project. So we have total 30 months, and now we are reaching month 18. Means by end of November, by end of this month, we are reaching the first reporting period. And at this point of time, we have three major milestones. One is we need to deliver the first version of software implementation for the platform for the vertical pilot deployments. And this is mainly from WorkPack 3, and they will have to deliver both D3.3 and D3.4 to provide this outcome. And the second milestone is about the first validation of the vertical pilot in terms of the KPI evaluation, including the initial experimental results. In addition, we also have the economic analysis from the WorkPack 2.1, focusing on the methodology of the business validation and the business model, and also they provide the first version of the economic analysis report in the D1.2. So these are the three major key achievements for this month's 18 milestones. So if you don't have a question, I will go on. In this slide, I will show you the overall structure of the project in different work packages. So in total, we have 4 key technical work packages. So the first one is the work package 1. They are mainly focusing on business validation, and they firstly analyze the use cases requirement from all the 4 vertical pilot, and they derive their functional technical requirements. And then afterwards, they are working on the economic study and building the methodology for the business validations, and also considering different stakeholders. The work package 2 is the innovation work package. They're leveraging on the Transformer platform. And on top of that, they are developing a select set of innovations and to enhancing the support for vertical to control the resources for the vertical premises. In work package 3, this is also one of the important work packages which are dealing with deployment of the vertical pilots. And this includes to deploy all the components at the vertical side, as well as how to integrate with the ICT 17 platforms. On top of that, work package 4 is the work package to do the evaluation and validations. So in this work package, they are looking at the definition and specification of the service and core KPIs, and also derive the mapping between the service KPI with the core KPIs. And they also are developing the methodology for validation and also the measuring tools. And currently, they're working on the first experimental evaluation of all the pilots. So this is the structure of all the technical work packages. Okay. Here I was just summarizing very briefly about the major achievements of each work package during the first reporting period. The work package 1, as mentioned, they already delivered the D1.1 last year in September, providing the technical and functional requirement of all the use cases. And they also designed the business model for different stakeholders, including operator, vendors, also the service providers. And this year, they just delivered in August the second deliverable, which is focusing on the first economic study. And they derived the business model and the verification of SLA, and also give up the first version of analysis in this report. In WordPad 2, last year they delivered the first initial design of the service platform from 5Growth, and they derived the functional gaps by comparing to the transformer platform, and based on the requirements from the vertical pilots. So based on that, they derived in total 12 iterations. And in this year, in May 2020, this year, they released the first software implementation of the 5Growth platform, where a select set of innovation have been implemented. And this has been published on the open source GitHub and also on our website. Currently, they are working towards the release 2 iteration, and this will be finished in May next year, 2021. So WordPad 3, they started with the gap analysis to provide detailed analysis on the ICT 17 platform, and to identify what is the missing functionality we need to develop in order to deploy the pilot, as well how to integrate with the ICT 17 platforms. And they derived the specification of the in-house deployment for all the vertical pilots, and this has been submitted in April this year in the deliverable D3.2. And in this deliverable, they also have performed a very detailed and careful assessment of the COVID-19 impact. This was the time when we started with the COVID-19 situation, and we are having dedicated a lot of time to discuss how we overcome the situation and encounter all the problems we are facing, and this analysis has been very helpful for us to overcome the situation and catch up on the project in terms of the progress. And currently, as mentioned, the major milestone we are having is WordPad 3. They're going to deliver by end of this month about the software platform for the pilot deployment, and also the integration with the 2 ICT 17 platforms. So this including a software implementation deliverable, D3.3, and also a detailed technical report in D3.4. So in WordPad 4, they are mainly focusing on definition and specification of KPIs. This has been already delivered in May this year in D4.1, and currently they also are working on the first experimental validation without through the measurement campaign for all the 4 different vertical pilots. and this will be delivered as well by end of this month in TFAM 4.2. At the end, the work package 5 is about the dissemination, standardization, exportation. So several deliverable has been already submitted from last year until this year by now, and just would like to mention or highlight that we also have organized several events like online workshop with other 5GP project like 5G Dive, 5G EVE, 5G Vini, and 5G Tours. And this workshop has taken place in June this year. And we also organized a layer 1 to 3 webinar in July. In addition, we also have organized a 5G from theory to practice workshop co-located with the 5G World Forum. In addition to all these online events, which due to the COVID-19 situation, we are not able to have the physical event, but we are trying to organize more on the online webinar and also coordinating some event with other projects. And in addition to that, we also have like contribution to several 5GPP vertical white papers, and one of them has been already published in September, focusing on the vertical of using 5G technologies. And we also have filed 3 patents by now, and collected 33 SDU contribution, and 5 of them have been already adopted by the standards. And we also published 9 communication videos, and they are all available on our website. So this is the summary about the status of each individual work package, just highlighting the main deliverable and achievements. So yeah, I'm not sure. Do you have any question by now? Okay, if not, I would like to jump to the second part, which is the status of the deployment of the vertical pilots. As I mentioned, we have in total 4 pilots. 2 of them are Industry 4.0, 1 transportation, 1 energy. So in this presentation, I think due to the time, I would like to focus mainly on the first 2, the Innovalia Pilot and the COMAU Pilot. And the additional transportation energy pilot, I will give you a quick overview, but I will not go to detail on that. So maybe for the Innovalia Pilot, I can also, I'm not sure, Manuel, whether you would like to introduce, otherwise I can also present and you can give the additional comments.
Yes, it's great if you can continue. It's great if you can continue, so that we don't have transitions. But of course, okay. I will be here to complement with any details that can be interesting for the audience.
Okay, good. So I also have the Paula for the COMAU Pilot. So yeah, then let's start with this part. So for the Industry 4.0, the Innovalia Pilot, this is one of the use cases. I mean, they have 2 use cases here. I just select one of them, and that's the one they are mainly working on now. This is the connected worker remote operation of quality equipment. So in this kind of use cases, as you see in the picture, there will be a technical worker which will be remotely controlling the kind of CAN, this kind of coordinate measuring machine, in another facility of the industry. And this facility could be either in the same location of this person, or can be quite far away in another city or in another country. So this leveraging us the use of 5G to provide this kind of communication to allow this kind of use cases. So in this use case, we will have 2 slides. First one is the person using the joystick to remotely control the CAN machine in the other facility, and this will require low latency. So this is ultra low latency slides, which have the requirement about less than 5 millisecond end-to-end latency, and also the high reliability, about 99.99%. And the other slice is the EMBB slice, which is used to transmit a 4K video. And this video server actually streaming the video about how the machine is being configured at the same time when the operator is configuring with the joystick. And this will give showing at the display for the this operator. So in this use case, 5G is very important, and I also can show you the result later why 5G is the one can enable such use cases. So 5G is used here to provide high data rate, to ensure the reliability and guarantee the low latency. And the benefit of this use case is that basically with the remote operation capability, you don't need to send experts to travel to the other location of the facility of the customer or the same industry. Then you can save the manpower as well as the time and cost for the traveling. And especially it's important in the COVID-19 situation, it will be very beneficial to enable such kind of use case for the industry scenarios. So in this use case, we have the Innovalia as the vertical, we have Telefonica as the operator, and the hardware software provider from Ericsson, and we also have the InterDigital provide the video streaming service, and the telecarrier is the operation support providers. Okay, this is the story of the use case, and this line show you how we deploy it. So the Innovalia Pilot basically will be deployed in two phases. In the first phase, the implementation, deployment, integration will be firstly take place at a lab environment. This will be in Photonic. And this is where we are now for the by month 18. And then in the second phase, so after month 18, we will going to move everything to the vertical side, and then this will be completely deployed at the Innovalia premises. And this will be for the final validation and testing. And as you can see in this picture, this is all the hardware software component of the pilot. So from the left side, you can see the operator, which is remotely controlling the joystick. And then it will have the joystick and also have a monitor to see the video. And this will create like two slices. And this user will connect with kind of CPE, 5G CPE, and connect to the base station. And this will connect to the other side, the factory side, remotely and through the 5G core network. And this in the middle, you see there are two platforms. One is the platform provided by 5G EVE to provide the mobile core. And then we also have the 5G growth platform, which is to managing or deployment of the vertical vertical applications at the edge, so at the premises of the verticals. And then on the factory side, you see all the different machines, the CNN, AGV, or the other machinery. They will connect with the 5G base station via the 5G CPE. And you also see there have also the corresponding slides for the low latency for EMBB, also for the for controlling all the different machines. So so this is the overall of the infrastructure of the pilot deployment. I'm not sure whether Amanda, you would like to add something here.
No, maybe just commenting that the stage where we are doing all these tests in Photonic Lab is a good way to reuse all the deployment of 5G in there and all the tools provided by 5G platform, so that you can have an extensive validation test in a sort of neutral lab. And then all the learnings can be taken, as well as all the developments for testing to the actual field in Bilbao premises, and that will come actually after this first milestone that she was commenting. So it's two stages that deliver good value from the pre-existing infrastructures, and then later on for the actual field where this type of solutions are going to run commercially.
Yeah, thank you, Manette, for the additional statement. Okay, so here is one picture about the vertical equipment. I think this is in Vitonic, and this you can see how we build up the pilot in the lab environment, and you can also find the detail on the YouTube video. In addition, there's this is the link for the YouTube for this video, and see how the detail of how we set up the test environment in Vitonic.
Yes, and this means if I can comment that
sure.
It's not that we are recording videos; it's that we are present in the lab remotely with immersive experience. There is a 360 video camera being recorded. It's accessible through any player of 360 video from your mobile phone, from your computer, and with a certain delay introduced by YouTube, you can also follow that in a standard channel of YouTube. So that was an important asset to overcome some of the problems with the COVID limitations for accessing the labs. And it's an asset that we use for many other projects as well. So I wanted to comment that and also thank, by the way, the progress in 5G with Carlos and with Lourdes in similar setups for actually virtual reality experience. I think this is important, that we are reusing as much as we can from other experiences and then taking them to improve our processes of validating and researching.
Yeah, excellent. Thanks a lot, Manette. Okay, so now I will move on.
Can I ask a question about this use case?
Sure,
if I may?
sure. Yes.
I just want to understand because we're talking about the servicing, the technician, is the provisioning time for slices, the creation, the tear down also considered, or are you assuming that the slices are already there and permanent? What is the assumption?
In the current setup, slices are selected, so they are pre-provisioned. The service here is sort of something bookable for this specific hour, or in 5 minutes I want to have this everything up and running so that I can calibrate remotely this 3D scanner. So yes, and that is actually a KPI that we consider, that we can comply to that within a limited time. But the environment we consider is that in the factory environment, so to say, there is a pre-configuration of the network, and then there is a selection that can be done in runtime, so to say.
Okay, so from the end customer point of view, the service, you will measure how long it takes to set up the service, or not?
Yes, I mean, in the case, if you are using the service in a sort of a booking table, then that's procured. If you want to use it immediately now, which is not the case, because imagine that what we are replacing here is the process of people traveling, taking a flight, and going to a remote factory to calibrate these machines. So it's normally planned, but it's something we measure very carefully, the instantiation of what we need to have the service running. The two slices that you could see, one for the control and one for the echo of the video back to the expert.
Yeah, right. And
it's KPI that we normally measure in all these experiments.
Right. I think that was where I was heading, like compared to sending the technician,
exactly.
the response time that you can expect.
Yes, the gain is immense, only for that reason. But of course, we have to validate the technology, and that has to do a little bit with, I think, the next slide, and we will comment more on that. We have to prove that this is feasible, and not only that it's a good idea, and this is the current ongoing work, actually.
Yeah. So if Manuel, if you may allow, so I would like to just mention. So at the moment, the measurement we are doing is that we already provisioned the slice. So I think it's static, but in the next version, that's what we are working on. So once we connect the platform, and this should be able to, I mean, we are delivering the software implementation of the integration of EVE and growth by the end of this month. So we are expecting next year beginning, and we are able to deploy the service, I mean, instantiating the slides with these two platform and connecting, I mean, providing the end-to-end slide solution. So there we can measure how much time we will use for set up the slice. But at the moment, the measurement we are doing now, we are still the one I'm showing is still the static slice.
And do you have any expectation about maximum time that it may take? Is it in the order of minutes, hours?
So if you see here, actually the KPI we need to derive, or you need to ensure the creation time should be less than 5 minutes.
Okay,
exactly. Yes.
So I think we just need to be sure we can achieve that. So based on the project from Transformer, we usually can reach the service provisioning time in the order of minutes. Okay, I hope I answer your question.
Yes.
Okay, thank you. So then now let me just show you the first experimental result. So yeah, in last few slides, you see the setup in the Photonic lab. So here is the logical architecture of the experimental setup. So you see there will be two slides, one for the radio one for the EMBB slides, and the other one for the joystick with the ultra low latency slides. In this setup, I think the scanner and joystick are kind of emulated on a PC, and they will connect to the 5G CPE. So this will be provided by Ericsson or a different vendor. They provide this to connect the end device with with this component, and they will connect with the 5G base station, and then there will be the 5G base station will be connected to the 5G core network, which is photonic. And yeah, as well for the video slides, the EMB slides, there will be this two component, one for the camera, one for the display. They will also connect to the 5G CPE, and they are sharing the same 5G resources, radio resources. So this is the setup, and on the left hand you see the KPI requirement for the use cases for different component. There will be like, for example, say the service creation time, also the latency and throughput requirement for the video slides, for the ultra low latency slides, and also for the second use case they have an AGV control, and also for the other control system they have also the requirement on the end-to-end latency, throughput, and availability. So here the table below, we have performed a very preliminary measurement result to just benchmarking about the current technology of 4G and compared to the result we have obtained with the 5G non-standalone version. So in this table, you'll see we mainly measure the round trip time latency and packet loss, the throughput for uplink and downlink, as well as the jitter. So this table shows you, so the 4G basically failed to satisfy the KPI required by the, for example, joystick slice, which require latency of less than 5 milliseconds. And you see 4G are actually in the range of 23, 24 milliseconds. And with the 5G node standalone, we achieved the round trip time in the order of 6.56 milliseconds. But so you see the end-to-end latency is one-way latency, so the round trip latency is a two-way. So therefore, here we are satisfied the required KPI on the latency, and as well with the 5G node standalone, we also achieve the required throughput compared to the 4G, and same for the jitter. Okay.
Slight clarification, if I may, because I know we have time to watch. is that for latency is what we really deliver for this use case, because it's the end-to-end communication of two devices, actually human to device, with two stages of radio in the path back and forth. So the total loop of time is what we have to verify that is all right for the application to behave properly. So that's the important thing, that this works for the application, not that we get a figure for the 5G network that we know very well. That is the first comment. And on the throughput, we always have to be extremely careful with reading the measurements, because what they mean is what the network has delivered to the demand of the service. So it's normally the demand of the service what limits the value you get. So you could go up to 70 or 80 megabits per second with no problem with a 5G network. But for this use case, what the service demands is at that level, and it has been delivered by the 5G network with a very low or zero packet loss all along the execution. So I just wanted to comment. I mean, there's many things to comment, but the important thing is that we are playing here with both vertical and the influence on the network, on the possibility to change the distribution of the application and get a benefit for the technology and for the business.
Yeah, thank you, Manet, for this comment. So I think in addition, the key messenger in this measurement is that the 4G as our benchmark failed the certification of the KPI, and that's proof the 5G is the technology we can use to enable such kind of use cases. Okay, so in addition to the previous result, they also have additional result, and one of the result is they have to derive further with two different non-standalone model. The first one is using the DDD with 3.5 gigahertz frequency band, and the second one is with extra adding to with extra LTE 20 megahertz per bandwidth. So in this result, we have more measurement regarding the latency, and as well as for the peak throughput for both the scanner as well for the video streaming. As you see, we are able to reach very high throughput in this table. In the right-hand side, this shows a measurement regarding how the impact of the distance on the KPI we achieved. So imagine we have the operator in Innovalia, and then there will be a manufacturing site in the other part of the Spain, so that will across the country, and therefore the distance is a key to impact as well on the latency. So this figure mainly shows how the latency KPI degrades when you have longer distances. So here, I think below 500 kilometers, everything's still fine, but starting from above 100 kilometers, so the performance degrades, and that it's also range we have to be careful. Maybe some of the KPI are not able to be satisfied. So this is this is part of the result, but Manuel, if you have more additional comment, you can please welcome to add.
That was super clearly explained, Xi. Again, what we try to do here is learning. We don't have a prefixed target of what the distance between the controller and the remote scanner should be, but we are going to find that out with validation tools, with a little bit of engineering, and at an affordable cost. Imagine doing this in real field or commercial situation, but we can test this type of things in a lab like 5Tonic and fully verifying in the final premises in Bilbao next year.
Yeah, thank you very much. Do you have more questions? So I think this so far for the result for the Innovalia Pilot for the first use case. So this is just summarizing the current achievement and what's the goal. So basically, after November, they will plan to testing this use case with physical deployment with the standalone, as well in photonic environment, and then also to for deploy the 5Growth platform to managing the deployment of the vertical applications at the edge, at the vertical sites. And then in that case, with the integration with 5G EVE, we are going to demonstrate the end-to-end deployment of the whole service of these two slides. Okay.
One small question on slide 14, just because I don't want to disappoint Diego or Carlos, being the chair of the INT area. Are you considering IPv6 at all? Or are you only basing the tests on IPv4?
Since you named me, Juan Carlos.
Yeah, I'm just trying to figure out.
No, I mean, as far as I can tell, the plan is to use IPv4 for the moment. In other projects, we are precisely starting to consider the use of IPv6 addressing for building a much more transparent address space that doesn't require, if you move functions over the different infrastructures that don't, this doesn't require reconfiguration of the functions, etc. Here, I think that for the purpose of these pilots, the use of IPv6 or IPv4 is, I mean, it would be a little bit immaterial in this particular case. If we achieve results in these other projects, and hopefully we will be able to deploy this on the photonic infrastructure, we could make a test. But as far as I can tell, they are not part of the current plans.
Okay, fair enough. Thank you.
So there are more questions for the Innovalia Pilot?
Yes, just one curiosity about the, is it going to be tested or is planned to be analyzed, the number of scanners or the architecture, how many people controlling by joystick the scanners in the factory, how many people can support the architecture can support?
I can answer. This is Manuel,
okay.
even if Asier could provide a better insight. In general, we are, again, replacing the need for traveling to go for calibrating or programming a remote machine. So in general, it's one-to-one. But of course, the model is that we are taking the intelligence to the edge and that we can have several experts working in Innovalia accessing remotely different factories where they have deployed their system, their metrology systems. So we don't have the problem in the factory, the problem of concurrency, even if it's the normal type of test of recurrence that we take in the lab. But we can have it, and we will test it in Innovalia, in the place where the experts sit and remotely control and calibrate the systems.
Yeah. So if I may add, so we're also considering how the scalability of the service is. So this is related to also one of the innovation we are also developing in WordPad 2 regarding if you have multiple instances of the application or the services of the internal VNFs. So we are looking at how we can automatically scale up or down of the services based on the needs. So imagine you have more devices or scanner or something required at the factory side, and this implies you need to have a multiple instance of the application. In that case, we are considering how we are scale up services in an automated manner. If this is the question you are asking.
Yes, I was asking about an analysis of the bottlenecks or any issue affecting the scalability of the use case.
Yeah, this is we are considering as well. but this we are still evaluating, but we are basically try to analyze the application and to yeah, depending on which of the application will be the bottleneck, and we are enabling the scaling capability of the service.
Okay.
Thank you.
Thank you.
Thank you. So I think that's all for the Innovalia Pilot. Thank you for all the questions. So now I will go to the COMAU pilot. Carlos, we have still enough time, right? If we can go more detail on the this pilot.
Since we are getting questions on the fly, yeah, I mean, we have like a bit less than 40 minutes until the end of the meeting. So,
okay.
I mean, we have to still leave some time at the end for additional discussion. So just keep that in mind. Thanks.
Okay, I will try to keep up the time. Okay, so this is the second Industry 4.0 pilot, which is from Italian site. One of the first use case they are looking at the digital twin application. And as by the name, the use case is to create a virtual reality of the production line with the application, and then 5G is used to deploy kind of real-time visibility and remote insight to the status of the production line, and without actually working or operating on the physical equipment. So in this setup, you can see this is the deployment of this infrastructure of this pilot. On the device side, you will see there will be one 5G smartphone, which can be used to give the command to the robots, and then there will be one real robot, which will be connected to a 5G terminal, and then in addition, there will be another 5G terminal connect to our PC, which is running the digital twin application. And this application also connected with HoloLens for the end user to see what is actually operating or configuring at the real robots. And all these 5G terminal will be connected to the 5G NR base station, and this will be provided by Ericsson, and these they are connected to our shared transport network from the COMAU vertical premises to the operator side, which will be located at TIN premises, and so there will be also a virtual EPC provided after the transport network, and this will be operated with the 5G growth stack. And in this use case, there will be two slides. One is the EMBB slides to provide the video transmission to the HoloLens, and there will be another slide for the ultra low latency to provide the feedback and control of the configuration of the robots. So the key KPIs here is also the reliability, and the latency need to be less than 50 milliseconds, and bandwidth is up to 250 megabits per second. And also there will be a requirement for the density of the device and mobility and the coverage of the area. So for this pilot, you also can see the video, which is already available on the website, on our project webpage, and also available on YouTube. And just want to mention, this pilot has been also already selected as the top 10 list of the second brochure of the 5GPP trial and pilot collection. So this also has been a great achievement for this pilot. I think this is the only pilot among all the ICT 19 projects. Okay, so this is the first use case, and now I'm showing the second use case of the COMAU pilot. This one is about the telemetry and monitoring application. In these use cases, they are actually gathering all the sensor or monitoring data of all the robots through the 5G to provide the monitoring information to a remote monitoring platform, which is an industrial IoT platform, which will be located at the team, the operator site. And in the vertical side, they will have deployed the 5G CPE to connect to different robots. And they will also have a gateway, which is collecting all the monitoring data at the COMAU site. And this will they will be all connected through the 5G in our base station, and then transmitted through the transport network and go through the 5G core, and then to the team premises via a VPN connection. In this use case, there will be machine type the massive machine type communication slice. It's needed to be able to connect a huge number of sensors, and also the ultra low latency slice is needed for the quick reaction of the failure in case they would trigger an alarm. So yeah, so this is also this use case also has been included in the video. You can see it as well later on. I'm not sure, Paula, do you have some more to add for these two use cases?
Keshi, you provide very good input, so quite complete. Yes, we are just to mention that the use of the transport network in this scenario, especially for ultra low latency use case, try to demonstrate the capability to realize a shared network in case where usually you have a dedicated network. So we extend this type of experimentation also the existing scenario, for example, from Asia, where some critical use case in general are provided only on dedicated network, and this opened the way to new use case where based for SME or other, just to complete the aspect you already mentioned, Shi.
Yeah, thank you, Paula. I think, yeah, you add one good point about the transport network. This is one of the innovation also we are developing for this pilot. As mentioned by Paula, the transport network actually is also the key to provide a low latency requirement for fulfilling the KPI, the latency KPI of this use case. And I think there could be two options. One, the transport network can be dedicated to only this vertical, and in the future they could be also shared by others. Right? This is one of the technology innovation we are also investigating in the project. Okay. So now I would like to just show you some first experimental result. So here is the lab environment from Ericsson, Italy, to conduct this experiment, which is just focusing mainly on the transport network, which is the based on the exporter optical technologies. In this measurement, they try to vary the different packet lengths, the size of packets, and then try to measure the latency through this transport network. So this figure is showing the average latency, which can be achieved on uplink and downlink, and the round trip, the total round trip time. And this, the lower part is showing the measurement about the throughput on the downlink and uplink with TCP with the iPerf application. And overall, so the measured round trip time we can achieve is in total 20 milliseconds, and the packet loss is in the range of 2 10 power of -6. And SUPU we can achieve on downlinks around 356 megabit per second, and uplink is 22.8 megabit per second. So yeah, Paula, I think you would like to add something.
Yes, exactly. The measurement end-to-end you see about the uplink, downlink have been done directly in COMAU by the other Ericsson lab, directly in COMAU on the mobile infrastructure that can be installed in the COMAU premises. And at the moment, we are trying to improve this measurement with understanding some tuning on the infrastructure, mobile infrastructure with the scheduling and something like that. So just to mention that we are also investigating the several methods of configuring the infrastructure in order to have an end-to-end suitable for this type of use case. At the moment, we have not integration with the transport, but will be done next year due to the COVID aspect, because we are only able to set up the infrastructure in COMAU, the mobile infrastructure in COMAU, but not the integration of the transport part.
Yeah, thank you for the additional explanation. Yeah, so as I said, this is still ongoing work on doing the experiment and collecting the result, and all the detailed result will be reported in the deliverable D4.2. So which is due by end of this month. So I just give you a selected result I just collect, but this is not the only results we are having. Also, I would like to point out, as by the measurement we can see the KPI in terms of latency and SUPU, we are measuring actually already satisfying all the KPIs we require by the both use cases.
Can I ask a question?
Sorry, yes, yes.
Slide? Actually, on slide 18, probably.
Okay.
For the MMTC profile, I see the connection density of 5,000 devices. So I have two questions. What type of radio interface are you considering? Is it a new radio or NB-IoT type of interface? And the second question is whether you are going to validate the density of devices.
Paula, you want to take the question or me?
Yes, at the moment the number of sensor is limited, and is in our interface, and then we don't know. Maybe we are able to extend to the entire line, but we are not sure. So in this case, the idea is to move the robots in different area and to increase in some way, to emulate in some way the sensor. So at the moment is the interface and air, and at the moment is related to the interconnection of the single robot of the entire line.
Okay, so if that is the case, is there a big difference from this profile compared to the other profiles? Because it's the same video, and I'm just trying to figure out if there's some peculiarity about the profile.
No, it's not different. It's exactly that profile.
Okay. Okay, thanks.
Okay. So more question? Okay, so here just summarizing also the status and the next step for the COMAU pilot. So yeah, I think the deployment has been partly done in the lab environment, and then the transport network deployment as well has been already finished. The next is integration, right, Paula, to the with the vertical sites, and the measurement we have already the initial measurement from the lab, but this is still I mean there are more results will be prepared under preparation and will be reported in the 4.2. Yeah, in addition, there will be the innovation implementation in terms of the how to support the round slicing. This will be also integrated into the COMAU pilot in the future. I think this currently, due to the convoy restriction we are having, yeah, this will be after the month 18. So, yeah, Paula, is, I hope I clarified the next steps.
Yes,
quite.
Okay, yes, it's okay what you said, and it's complete, and exactly due to the problem of COVID, we are a bit limited, and anyway, the transport network is complete, so we have just integrate as the 5Growth platform implementation. Next week we have some new meeting to understand how to manage, because depends on the restriction on the country that we have due to the COVID. This is the point.
Okay. Thanks a lot, Paula. So, any more additional question for COMAU pilot? Okay. If not, I think due to the time, I mean, actually, as mentioned, we also have the transportation pilot and the energy pilot from Portugal, the IFSEC facilities. But I would not go detail to these two pilot. But I this including in the slide. I can give you very quick walk through, but for the detail, maybe we can discuss offline or at the end if you have more questions. So the transportation pilot, they are having two use cases. One is for safety critical communication, the other is for the non-safety critical communication. This use case mainly to using 5G to enable more safety critical communication, to control the crossing for the chain, to detect the chain is coming, and there will be a cross control, and they will also control the detection of the sensor about the arrival of the chains. So this pilot has been also having a video available on the website. You can also check this later on our website. And the second use case is mainly enhancing the first use case by providing the video image about the transmission of the image of the situation to the workers, the maintenance team, and they were using a 5G device like a tablet to look to have a video image about the situation, and the same time this image also giving to the driver of the chain. So this is the second use case. In the same, so they also have been working on two phases. So the first phase, which is the focus right now, they would deploy the partially of the pilot in a lab environment in EVIAB, and this the intention of this phase is to firstly testing all the requirements of the use case are able to be met before the real deployment at the vertical sites. And in the second phase, they will move all the deployment to the vertical premises, which will be in Porto and in the EVIAB harbor. So they also have already a set of first experiment focusing on the round trip time, and also some measurement on the throughput. And also they are comparing between the LTE technology with the 4G technology with the 5G communications. And with this, you can see with the 5G, we are significantly reduce the latency to in the range of below 10 milliseconds. With the LTE or 4G technology, this is the range of 60 to 100 milliseconds. Yeah, so the energy pilot, they also have two different use cases. This pilot is mainly
sorry to interrupt. Maybe for the sake of time, maybe we can just skip the energy pilot.
Okay.
Yeah.
Okay, fine for me. Actually, just 2 slides. Okay, so I will also be very quick with this part. So since we both all of the pilot but require the integration with the ICT-17 platform, and in our project we're just working mainly with the EVE and VINI platform. And here I just would like to quickly show you how we are addressing the integration solutions. So for all the pilot, the scenario is that we will have vertical sites, and they will be managed by the 5G growth stack, and then they will be accessed by the verticals, and to provide all the edge functionalities, and then they will require a connection to our ICT-17 platform, which is having a role of the public network to provide all the 5G end-to-end infrastructures. So yes, so this is the more like architecture level solution for how we connect with the EVE and with the VINI facilities. So in our architecture, we have one component called vertical slicer, and there we have derived a module which will provide the interface to connect to the 5G EVE portal to request a subset of the vertical services to conduct the experiment on the 5G EVE sites. And similarly for the VINI, we will also have a different API or interface to connect to the VNet portal, which is mainly providing a never slice as a service functionalities. So for the EVE, they also require some interaction on the service strata level to enable the never service composition and federation. So this shows all the required interfaces and interconnectivity between the 5G growth platform and with these two ICT-17 platforms. So here is one slide about the solution for the EVE. As I mentioned, we will require basically the vertical user. They either can, through a web-based interface, to access the EVE portal graphing interface, or they can also go to the vertical slice of the 5G growth stack, and from there they will have the interface. So by means of the REST API, can connect to the 5G EVE portal, and then they will through the EVE interworking layer, and there we'll have our 5G growth facility plugin, and this will be the entity to connect with the service generator component and the 5G growth site. And in this case, they will vertical request the vertical service through the 5G growth platform at the vertical slicer, and then from there request the end-to-end service to the EVE, and then and some of the functions or service which need to be deployed at the edge or the vertical premises, and this will be through the plugin for the 5G growth driver to the service generator of the 5G growth platform. So this is the approach we have developed for the 5G EVE integration. And for the VINI integration, this will be only through the vertical slice of the 5G growth stack, and there we will deriving API and driver to connect to the Sonata-based portal of the 5G VINI, and they are requesting a never slice services. So yeah, so this is the solution, and currently by end of this month, this integration means including all the software implementation for the drivers, for the plugins, for both 5G EVE side and VINI side, as well as the 5G growth side. And this will be finished by end of this month as in the deliverable D3.3. And after the month 18, we're also going to do the testing of the integration workflow, and then to be tested in the different pilots. And also in the next year, we are also going to work on how to, in addition to instantiate only the services, also we need to look at how to managing the life cycle of the operation, especially, for example, I say how we can scale up certain services, and this will be part of the network service scaling during the operation of the vertical services. So yeah, this is the next steps towards the end of the project. I don't know if I still have some time, I can go very quickly to the innovation.
Yes.
Yeah.
Sorry, just try to keep it under 2 minutes, just to leave at least 10 minutes for additional discussion at the end.
Yeah.
So please really
Okay.
go fast on this. Thanks.
Okay. Okay, so the innovation I've already mentioned at the first kickoff meeting. So we this is the main work in WordPad 2. They're developing the set of innovation leveraging on the 5G transformer platform, but addressing or enhancing the vertical support in terms of smartness, flexibility, efficiency, automation, performance, and security. So accordingly, we derived 12 innovation in total, categorized in the framework, architecture, and algorithm side. And this is based on the innovation. We actually extending the baseline architecture from transformer, and we this is the extended architecture we have now. And so we basically adding 2 additional building block. One is the AI ML platform, which is to provide the AI and machine learning services to the 5G growth stack. And then the other one is the enhanced monitoring platform for supporting the vertical monitoring applications. So these 2 additional components are being developed to support the all the 5G growth 3 layers to do the manage the closed loop automation and service instantiation kind of services. So yeah, this is in addition, as I mentioned, for interconnecting with the ICT17 platform or any of the external provider domain. So we are having also have the integration in terms of how to provide the federation in the different level. So can be on the communication level, network slice level, and on the network service level.
Sorry,
And,
sorry to be always the one interrupting you, but can you maybe just go to the summary, just
this
because
is the last
otherwise
yeah,
but
last. Okay. Okay, sorry. Fine then. Now, let me go to the summary. So in by this point of time, we have been mainly focusing on the deployment of the 4 vertical pilots. As we have show you, we already have the, I mean, we are mainly structured in 2 phases, and now we are working mainly on the first phase, testing them in the lab environment. And the result on how the detailed deployment of each pilot, also along with the software implementation on the platform, will be delivered by end of this month in the D3.3 and D3.4. And we also will provide the initial pilot validation in the D4.2, also end of this month. And then in addition, as I mentioned, that one remarkable achievement is that the COMAU pilot has been already selected as the top 10 of the second of the 5GPP trial and pilot browser. And this is going to be published very soon. And COMAU and transportation pilot, the video can be also found on the website, also on YouTube, also in the Innovalia Pilot. And then for the innovation, we have the 12 innovation already designed, and the first release of the software platform has been also published in May this year, and we are now working towards the release 2, which will be completed by May next year. And at last, that we have the also provide the first version of the economic study, and this has been submitted in August this year in the deliverable D1.2. So the last information I will just show you is the achievement in terms of communication, dissemination, and exportations. So in terms of communication, we have already provided leaflets, posters, and we participate in several 5GPP working groups. And we have already published 9 communication video, including the one for the 3 different pilots, and we have 12 press release. In terms of standards, we have now already have 33 contributions, and 5 of them has been already adopted.
Sorry again. Okay. But I think that we really need to leave some time for additional feedback and questions, just to be on time, because I know that at least some of the guys on this have to leave at 6 p.m. sharp. Sorry to interrupt you again, but I would like to now open the floor for additional feedback and questions.
Yeah, well, thank you. I'm personally also, I need to leave at the hour. So 2 questions, and maybe you can take them into account if not for this one, for next round of discussions. I was just curious, coming back to the mobile the massive mobile type communications, MMTC profile, if that's going to be considered in some other of the pilots. And if so, what are the characteristics? That's on the technical side. And on the business side, I was also curious about details of the business model that I know you have already provided some deliverables, but I was just curious to understand what was the business model considerations and proposals that you had in mind.
Okay, shall we take this question now, or we answer you offline?
As you wish. I mean, I maybe offline so that I can leave time for other people to ask questions.
Okay. So I think were you? I'm not sure, Carlos. You noted the question, or some of us need to?
Yes.
Okay.
Yeah, I noted the questions, and actually we will also have the recording anyway. But yes, I took note. Thank you very much, Juan Carlos, for the questions. So, any other questions from Carlos, Lourdes, Enrique?
Not from my side. Thank you for the explanations.
No, from the side, from CETITUR. I mean, congratulations, for all the work, all the well done, all the effort that you've done in everything related with the different pilots and applications. And no, I don't have anything to add. No, thank you so much.
Okay, thank you. So, Carlos, how much time do you have?
Right. Yeah, I think Enrique wanted to say something.
Yes. First, congratulations and for the good work that has been done. And for me, I consider the industry 4.0 very interesting, along with the transportation use case. The reliability of the communications and low latency are very important, and as I already mentioned, the scalability and the coverage, and of course the node density needed to achieve the required number of devices and cover the area are important issues, and you have reflected that in the KPIs. And just thank you for the presentation.
You're welcome.
Yeah, thank you very much. So I think we can close it here, just to be on time, and for sure we will address Juan Carlos' questions offline, and we will provide our answers. And then in the future, probably after our project review that is going to take place on February 11th, 2021, we will try to schedule another meeting with you guys to share the feedback that we got and share also our intentions for next steps, also considering the feedback from the reviewers. So again, thank you very much for all the very good input and the feedback, and we will keep you updated in regards of our progress. So I don't know if any other of the people from 5Growth wants to say anything else. Any final remark?
No, just excellent questions and feedback, and we will keep in touch for details that will be interesting to discuss and share.
Okay, thank you very much, Manuel. Thank you very much, guys.
Yeah.
Thank you.
Also,
and
thank you from my side. Thank you. Bye.
Excellent.
Thank you very much.
Thank you.
Thanks. Bye.
Bye.
Thanks and take care.
Bye.
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 Bye.